Okay, we are now looking at unit test questions. This is solving compound equations and inequalities unit tests. So solving for t, nothing new here really. We're going to take the numbers and put them on to the right hand side using the golden rule of equations and inequalities. And then we're going to be left with 12t is less than negative 5t plus 38. And then I'm going to add 5t onto this side. You just have to remember that the only time you switch the signs is when you divide or multiply by a negative, not when you're just adding or subtracting negatives or anything else. So this is 17t is less than 38. Nothing's changing in the sign, inequality sign. And then we're going to get a fraction, so we're going to divide by 17 on both sides. And the answer is t, and you have to write, I believe you have to write all of this in the box when you put it in there, 38 over 17, and that's it. Don't think there's anything else you can do that with. 17 is a prime number, meaning it can't be divided by anything other than 1 and itself. So moving right along, this kind of question, solving for x. This is our compound inequality, and through this kind of question, basically you really have to kind of work it out ahead of time. I should have left more space to do that, but here, we'll do that now. We'll create some space to work this out, and then we'll go ahead and do it, and you'll see that there's only really one answer that you could possibly have here. So we're going to simultaneously work these out, solving for x on both inequalities, both sides. So minus 8x is greater than or equal to 24, and then we're going to divide by negative 8. Guys, remember, when we're dividing or multiplying by a negative, the sign is going to change. So x is less than negative 3 on this side. This side we're going to take negative 5, and we're going to then solve for x that way. We're going to get negative 13x greater than or equal to 52, and divide by negative. Again, we're dividing by a negative, so we are going to end up changing the sign. So x is less than or equal to, and this is going to be negative 4. So now we preserve the and, nothing has changed there. And if we were to, there's only one answer, and it's down here, but we would want to rewrite this. So we want to write it as just x in the middle, less than or equal to negative 4. And x also is less than, facing the same thing. It's greater than or equal to, this is a little tricky. It's the way it's written is it's less than or equal to negative 3. But the answer in here, it's kind of flipped it around. It's definitely the only answer that there can be. But let's look at a number line and let's see if it actually makes sense. Less than or equal to negative 4. So less than or equal to negative 4 is going to be this way. So it's going to be negative 4 and all these dots here. And then less than or equal to negative 3 is also going to go that direction. So it's actually going in the same direction to the left, because anything less than a negative number is going to be things like negative 5, negative 4, etc., etc. But we have a bit of a problem here, and that is that we are getting a contradiction, because it looks like this over here is not going to be the one we think it might be, because this is saying x is less than or negative 3, which is what we have, but it's saying x is greater than or equal to negative 4. So that's not what we have up here. This is a very tricky question. Actually, the solutions, if you look at them carefully here, are going to be everything less than or equal to negative 3, right? Because negative 4 is already contained in that, so we don't have to say that again. Negative 4 is part of that already. So actually, this is our answer. It's a very tricky question, guys. You got to be very careful. You definitely want to think about these. You definitely want to plot them out, use a number line, think about what the solutions really are before you dive in. And it was very tempting to just answer C. But as we worked it out, and you can see I really went through the whole process of really looking at these signs and really checking it, I realized, okay, Actually, this is not correct because x is not greater than negative. We're going to make it -4. It doesn't say that. X is less than or equal to -4. And they were also checking to see if you switch those signs and if you're really confident about switching the signs, because some people would have been messed up by that. This is a classic example of distribution. This is going to be 8 or 10k when you multiply by 4 times 2.5, and then it's going to be plus 5. So it looks like the multiplication is actually going to sort out your there you go, 12k. That's going to sort out everything there, make it a little bit nicer for you. 12k. There you go. Right. So now solving for we're going to subtract 5 on both sides. We want to get the 5 on the other side. We're going to subtract 12k. So we're going to get 10k equals 12k. I like to take my time and take all the steps. Never compromise on that. You notice I never sort of try to do two things at once. Not a good idea. Because these things can be trickier than they look. And why rush it, actually? There's no real reason to rush anything at all. And now we're going to just go ahead and we're going to get -2k. We're just gathering it all up is equal to -5. I'm almost done. I'm simply going to then just divide by -2. And we're going to get our answer over here. It's k equal to -5/2, or something, maybe people will say -2 1/2, possibly. But I think most people are going to be happy with the -5/2. And that's it. That's the answer right here. Well, let's look. In fact, I think they actually said do not deal with mixed numbers. So I think we wanted to leave it like this because I believe that's the only way the computer will let you answer it. It's like a P over a Q or something function. How many solutions to this one? Is it no solution, one solution exactly, or infinitely many? We've been here before, right? We're going to distribute that. We've been here because we know we're going to take this as far as we can just to sort of get a feel for it. Is there going to be any false or absolutely things that are totally true, or anything that's completely false in terms of statements? Let's see. -6x minus 42 equals -4x plus 2. And then we are going to add 4x on both sides. We get -2x minus 42 equals 2. Add 42 on both sides, and we're going to get on this one, I'm trying to just create a little more space for myself here just so we can work it all out. We get -2x equals 44. When we divide by -2, we're going to get x equal to -21, I believe, right? Yes, no, -22. I spoke too soon. So is that no solution? No, that's a solution. It's not infinitely many either. There's only one solution. It's unique, and it is x, and it is -22. That's it. That's what we find. That is your most standard kind of answer. It's B, one solution exactly, because that's generally what people are looking for, is that kind of stability, and looking for that perfect answer, the one unique answer. In this case, it's -22. Other systems end up being unstable and giving us something like no solution, where you get something like, 5 equals 10 or something absurd. Sometimes, of course, you get infinitely many when you get something like, 7 equals 7. That's always true. But that's it, guys. That's our series. I've got 4 different videos for 4 different types of assignments, 3 quizzes, 1 unit test. I hope this helps, and I hope you ask questions if this didn't help, or if you need more help, or if you have advice or anything you'd like to see in these videos, let me know. It's Day Teacher or Mr. Day. Thanks so much. Bye-bye.